Hi everyone, so welcome to my YouTube channel. So today I'm going to be talking about what is actually data science and my personal experience and journey into data science and an insight into what I actually do on a day-to-day basis, or what I did in my previous job as a data scientist. So in terms of my background, I started off my career in consulting when I graduated. Then it was mainly technology consulting, mainly digital transformation and consulting. Then I moved into data analytics, my first kind of sort of data role within, after graduating from college. Then after doing data analytics, I moved into data science, pure data science, and helping to build out products within data science for a tech company. So that was my journey. So from consulting to analytics to data science. And so I'll probably do another video at some point, exactly how you can transition from a more commercial consulting role to far more technical data science roles. I'll probably do another video on that. So first things first, so in terms of data science, so I would say the core of any data scientist, before we go into the more complicated stuff that you kind of see in social media, etc., making all those cool technical data science products, it's the core of it is understanding the data and understanding how you can use data to align with business goals. So a lot of data science is about understanding data, analyzing data, and forecasting or measuring how the business is doing compared to what the business goals are. So that's like the core of data science, like understanding data, understanding how the business is performing right now compared to what the business goals are. So for example, it might be something in terms of revenue, or it could be user signups, something that the business is measuring in terms of their goals, and also how the performance of the business is doing. So how is the data measured compared to what the business goals are? So that's the core of it. So that's what you see in terms of when people mention data analysis or looking at data trends. That's what they really mean. So looking at how the business is performing as versus how or what the business goals are, or what the company wants to do. So I would say that's the core of data science. So in terms of what every data scientist does, there's always a component of data analysis. That's like the fundamentals in terms of data science. So number one is data analysis. So that's kind of the first step of the journey towards becoming a data scientist, delving into data analytics, truly deep diving into how the business is performing in terms of different metrics. So it could be, say, advertising or revenue, and you're measuring all these different components of the projects or business and measuring it to what the business wants to truly achieve. So that's the fundamentals, and obviously reporting it to stakeholders, etc. Now, once you go past this element of data analysis, data analytics, and you go more into, I would say, more advanced data science. So data science is still like a very open-ended role to me. There's a lot of autonomy that goes in data science. You kind of work on, there's obviously a direction from management, but you kind of work on really what you want. As I said, the core is data analysis and data trends and observing what the business needs are. But also you have to provide some sort of value to the business. So it's no use just saying, oh, this is the business performance and these are the goals. It's also really important to justify your value to the business by saying, these are data trends, this is the performance of your business, this is how I recommend what the business should do based on these data insights. So that could be tweaking some settings on the advertising campaign. It could be improving operations for a delivery company based on the data. It could be targeting certain countries or regions based on the data that's growing essentially. So there's also, once you get more advanced in data science, it's about recommending what the business should do from a data perspective. So that's a key component. So it's not about making cool technical products. Obviously that's great and all, but it's essentially about what you can do to help the business reach these business goals or improve or grow by producing these products. So this, when it gets a bit ambiguous or tricky, being a data scientist, so it's always important to learn, because once you're given a problem, can be sometimes a bit ambiguous about how to create a product or create an algorithm or use an existing algorithm to improve on the product. So it's, as a data scientist, kind of in a name, you kind of have to be a scientist and experiment with totally different methods, try out different things, because it's not as clear cut or as concise as engineering, where I feel like in engineering it's more a precise goal, where it's like, oh, we need to change the UI to this theme or this type, or we need to create a button that does X, Y, Z, or we need to connect an API that does this, translate a language, etc. Data science is a bit ambiguous because you have a certain goal that you can optimize for rather than fully complete. It's not like changing a color from red to blue. That's more concrete. Whereas data science is about, you have these goals and you have these metrics and you should optimize for these goals. So it's like, say for advertising, like you want to optimize click-through rates or cost per click for these campaigns, but it's not exactly clear as to how much you should increase the click-through rate or cost per click. So it's always a continuous process to improve on the current measurements and align it towards the business goals, or maybe even exceed those big business goals. So it's up to you as a data scientist to understand the data in terms of how the performance of the business is doing, but also find ways to add to the product offerings in terms of optimizing for a certain goal. So for me, there's kind of the most common products that data scientists do, or a company has a business need for, is one, improving on the metrics and optimizing for the metrics, and number two is recommending algorithms or recommending product features to users. So for example, on Amazon, it might be collecting all the user data and recommending products to users based on their search history, their user history, etc. So that might be one feature. Another feature might be Airbnb, where they look at all the user history data and they look at their likes, comments, etc., their views, and etc. They can aggregate it all and recommend these new products or these new properties to users based on what the user search for. So to me, there tends to be two common recommendations. So optimizing for certain goals or metrics, and also recommending products based on user search history. Those are the two most common ones. Now, the third one that's emerging now is obviously AI, and particularly with large language models. So you'll see a lot of data scientists nowadays, they might not have that complete experience of natural language processing, etc., or large language models, but data scientists are kind of bunched into that kind of AI realm, even though it's so vast and so broad. Data science often, I think nowadays, are trying to self-learn or about these large language models and chatbots, because their companies are asking for these chatbots or these AI tools that they can interact with. So there tends to be kind of a few kind of chatbots that are like quite common or popular. So one is obviously a customer-facing chatbot that data scientists are asked to produce for customers. So it's maybe searching on the website and they want to ask questions through a chatbot. And the others are internal chatbots. So they could be internal chatbots for employees to answer questions, or they could be chatbots for data tasks. So internal queries on the database based on the internal data, and using large language models to get that data essentially. So those are the kind of common types of projects that you'll be asked to do as a data scientist. So yeah, in terms of on a week-to-week basis or day-to-day basis, a lot of time is spent on analyzing data, understanding the business needs. So aligning with the stakeholders exactly what you should be doing. Yes, there's a lot of autonomy as a data scientist in terms of experimenting, trying out different products, but it's really important to make sure you are on the same page as your managers or your stakeholders, making sure they understand what exactly you're trying to achieve, and being transparent exactly what you're doing to achieve those goals. So a lot of it's understanding data and aligning with different stakeholders as to what you should exactly be doing. And once you've aligned on that, now it comes to a lot of times experimentation and trying to understand these different algorithms, how they can fit together, and how you can use those algorithms to produce products or make features that will be useful to solve the problem space that you're in. So once you've identified some algorithms that you would like to try out, essentially you'll be making these MVPs, or very simple basic versions of these algorithms, where you're feeding in the data and it will essentially recommend a set of settings or features that should be applied to the tech products. So, and in order to understand which algorithms are the best, yes, you can have a hypothesis about which algorithm will do the best or which settings will do the best, but it's really important to do A/B testing. So A/B testing in data science is crucial. It's very important to do A/B testing in data science. Otherwise, a lot of it is just hypothesis or guesswork. So A/B testing essentially when you have one control product and one experimental product. So the control is usually the original of the product or feature. The experiment is essentially the new products or new algorithm that you want to try out, and you want to experiment between the two. So an example would be, a control might be, say, like if you look on, I don't know, Netflix, for example. So Netflix, it would say, it would recommend a certain TV series or movies to you, and it would have their own basic algorithm that they use. Maybe it's a rules base, so it would search on genre, movie length, etc. So it would look at that as kind of a basic control. The experiment would perhaps look at all the different data types. So it look at your view history, it look at what other similar users viewed, how, your past history of viewing, your likes or favorites that you put on Netflix movies or TV series, and it aggregate all that data and essentially pass it through the algorithm and recommend movies and TVs based on your likes and your history of using Netflix as well. So, and it would compare the two. And so usually most companies would basically do a basic A/B testing where it would split the users in half. So maybe like certain user IDs where they're even or odd, so split it completely in half. And you would compare as to, normally in these tech companies, it is based on the number of clicks. So if one control, one experiment had more clicks than the other, and it was a significant statistical increase, then it would be defined as a successful experiment. However, if the control and experiment are fairly similar, the results would be inconclusive, and you would have to rethink again, or maybe do a different experiment over time. So two things have to occur for an experiment to be successful: is that it has to be statistically significant, and it has to run for a certain amount of time. So depending on what you're measuring, in my experience, significant statistical uplift or increase would be around 5 to 10%. It depends on the experiment, but even maybe 3% would be significant. So anything 1% or less, that's not significant, I would say, in my experience. So 5 to 10%, even if it's even more, then great. So, but that's kind of what you're looking for. In terms of the time period or the time length, you're looking at around maybe like, these tech companies are usually quite quick, so maybe 2 weeks. Ideally you do 4 weeks for this, but 1 to 2 weeks should be enough. 4 weeks if you have the time though. So that should be enough. So once you have these A/B testing results and your experiment is successful, you would usually liaise, as the data scientist, liaise with management or engineering teams, but first management. So I would do a monthly solo meeting with very senior managers or management team, and I would liaise with them, and I would say, these are the experiments that I've done during the month, and these are my findings, and this is how my experiment increased certain metrics for the business, and I am confident or feel strongly for implementing this experiment into live production, or 100% for the product as well. So yeah, first aligning with the stakeholders, being transparent and communicating what your experiment results are, saying that, yeah, I'm pretty sure like this new product will improve the business, or improve clicks and improve measurements, optimization, etc. And therefore we should go ahead. And once you receive sign-off from senior level employees or senior management, then you can take this project and move it on to engineering. So this is one it's quite a long process for this in terms of experimentation, but once it's done, you will move on to the next step, where you liaise with the product managers and engineering teams to make sure that this is put into live production. Now, it doesn't stop there, because engineering will also have their requirements. I've experienced this many times myself, that engineering will say, oh, we need this data in a different format. This product needs to be made in a certain way to integrate with our system. So again, you have to make sure that you're aligned on both pages, and make sure that what you produce is compatible with the systems at the company. So once you do that, which often can take a bit of time because things can get a bit political. Obviously, engineering teams are busy with their own features, etc., and you're trying to push out your own product, make sure it goes live. So essentially, it's really important that you push these products to really quickly as possible to go live, because it can take much longer than you initially thought. So making sure you push these out, and making sure that what you do is ready for production, and then yeah, you can push out and go live, and you can essentially, after that, you can put it on your resume or your list of achievements at the company. And yeah, after that period of hard work, you can eventually be very proud of yourself in terms of the work you've done. So that's kind of that in a nutshell. So I would say there's kind of three main elements of being a data scientist. So one is obviously understanding the data, the performance of the business, and how it aligns with the business goals. Number two is aligning with stakeholders on what you're doing, making sure they understand what you're doing. And number three is experimentation and building products. So always experimenting what the best algorithm is, and pushing that product to engineering, and making sure it gets pushed to production for the company as well. So yeah, so hopefully that you found that useful, and I'll probably do a video at a later time telling you how you can transition from commercial careers, whether that be in consulting or something else, to a more technical data science role, if that's where your interests align. So hopefully you found that useful. So if you like this video, please comment, like, and subscribe, and see you next time.